Hello, this is Mr. Mac. I'd like to talk to you today about solving polynomial equations. Now, the very first thing that we're going to do when we start talking about solving polynomial equations is talk about factoring. And the question is, why would we talk about factoring when what we're really trying to do is solve polynomial equations? Well, so first of all, why is factoring so important when we're solving polynomial equations? That is because of the zero product theorem. Now, the zero product theorem says if you have a product, A times B, maybe times C, that's equal to 0, the only way that can be true is if either A is 0 or B is 0, or actually both of them 0. There is no way to multiply two non-zero numbers together and to get 0. So when we're solving polynomial equations, if we have a polynomial set equal to 0, and we can factor the polynomial, we can set each factor equal to 0 and solve each of those equations, and that will give us the solutions to the polynomial equation. Now, we've done that already with quadratic polynomials, which is second degree, but we're going to perhaps look at polynomials of even higher degree. So now what we want to do is we want to talk about factoring. Now, when you have a polynomial that you want to factor, there's a hierarchy or a checklist that it helps if you go through these. So what I'd like to do is I'd like to give you a checklist, a number. Check for this first, then for this second, this third, and so on like that. So in the checklist for factoring, the first thing you always need to check for is common factors. Now, let me give you an example of that. If you have, for example, 5x squared plus 20xy plus 4x, 40x cubed, and you're asked to factor that, first of all, notice there's a factor of 5 in all three of those terms, and there's a factor of x in all three of those terms. So if we take out the 5x, we can say to ourselves, 5x times what gives us 5x squared? Well, the answer, x. Plus 5x times what gives us 20xy, 4y. And 5x times what gives us 40x cubed? That would be 8x squared. And so we end up with 5x times x plus 4y plus 8x squared. Common factors. It is extremely important that you remember to check for common factors, and it is important that you get out all of the common factors, because if you don't, they will probably mask things that come along a little bit later than that. So, what's going on here? Okay. Now, I think we have the smartboard back under control now. I'm going to erase this part right here. This was an example. You can write it down if you want, but I'd like to put the next thing under the first thing. Okay, number 2. Once you've taken out all the common factors, you still need to look at the factors that you have and see if any of those will factor further. Now, the second thing you check for would be, are there any special products? And from time to time, we may add to our list of special products, but special products that we already have is difference of two squares. Now, a difference of squares basically is when you have a square, say 4x squared, and then you're subtracting from it another square, maybe 9y squared or something like that. they're pretty easy to see. And so if you had something like this, to factor this, you would say, all right, what do you square to get 4x squared? Well, 2x. And what do you square to get 9y squared? 3y. So this factors into 2x plus 3y times 2x minus 3y. That's a pretty easy pattern to factor, and it's a pretty easy one to see. And at this particular point, check to make sure. Check always to see if you can factor it as the difference of two squares, or the difference of squares. Now, the next pattern under the special products is the perfect square of a binomial. If you have a plus or minus b squared, and you FOIL, and you multiply that by itself through FOIL, you end up with a pattern that goes like this: a squared plus or minus 2ab plus b squared. Now what that means is, if you have a plus sign in the binomial, then you'll have a plus sign for the middle term. If you have a minus sign in the binomial that you're squaring, you'll have a minus sign for the middle term, but everything else is the same. Now, what I recommend that you do is you memorize this pattern and think of it in this way. A is the first term in the binomial, B is the second term in the binomial. So when you're squaring the binomial, you get the first term squared plus 2 times the first term times the second term plus the second term squared. Now that's when you're actually squaring the binomial, but now we're trying to go the other way. We're trying to factor. So imagine you have 4x squared plus 12xy plus 9y squared, and you're being asked to factor this one. Well, now first of all, you have to check to make sure that it fits the pattern, okay? And if you look at the pattern has two terms that are squares. And so in this particular case, do we have two terms that are squares? Well, yes. 4x squared is a square, because 2x times 2x will give you 4x squared. And 9y squared is a perfect square, because 3y times 3y will give you a perfect square. Now, the question then remains, is the middle term 2 times 2x times 3y? And it is. So now, since it is, you can simply say that's going to be a, 2x, plus the sign of the middle term, b, 3y, quantity squared. And you have factored this quadratic trinomial as using the square of a binomial pattern. So that's another pattern to remember and to watch for, but you do have to check to make sure the middle term works before you actually use this pattern. Now, the third pattern under special products is called sum and difference of cubes. And this is new, sum or difference of cubes. This is a new pattern that you're being given at this particular point. And the truth is, this pattern is difficult to figure out any other way. It's one that needs to be committed to memory. And so let me just give them to you. If you have a cubed plus b cubed, that will factor into a plus b times a squared minus ab plus b squared. If you have a cubed minus b cubed, that will factor into a minus b times a squared plus ab plus b squared. Now, I recommend that you memorize these patterns. They are similar to some others in some respects, but please don't get them mixed up with other patterns. And also look for ways of helping to remember. Some of the things that helped me when I was a student was a cubed plus b cubed. One of the factors was a plus b. And a cubed minus b cubed, one of the factors was a minus b. So in other words, whatever sign you have, the sum or difference of cubes, the binomial factor has that same sign, plus or minus. And the other factor was always a quadratic polynomial. And whatever sign you had in the binomial, you had the other sign in the middle. See, if you had minus here, you have plus here. If you have plus here, you have a minus there. And notice that the powers of a decrease each time. A squared, a to the 1, a to the 0, while the powers of b increase, b to the 0, b to the 1, b squared. And also notice there are no coefficients in any of these terms. These are just flat out terms with a's and b's and so forth. Now, sometimes you will have coefficients when you actually do a factoring pattern, but that's going to be contributed by the term itself. Let's take a look at an example. Let's say you have x cubed plus 27. Now, if the directions are to factor, you would first look at it and say, are there any common factors? And no, there aren't. And so then you would say, all right, is it a special product? Well, it's certainly not the square of a binomial, and it's not difference of squares, but it could be the sum of cubes. X cubed is a cube. Now, if 27 is a cube, then it would be the sum of cubes. So is 27 a cube? Well, if you think about it for a moment, you'll see that 27 is really 3 cubed. So we have x cubed plus 3 cubed. Now, that's this pattern. That's this. Let's see. Let's do this. Pick up the camera and move that over here. And we're going to take just this. That's this pattern right here. That's terrible. Let's grab that one again. Well, okay, I guess that's good enough. So what we're going to do is we're going to put the pattern down here next to our x cubed plus 3 cubed. Now, to factor x cubed plus 3 cubed, notice that our a is x and our b is 3. So whenever I say a from the pattern, I'm going to write x, and whenever I say b from the pattern, I'm going to write 3. So x cubed plus 3 cubed factors into a, that's x, plus b, that's 3, times a, that's x squared, minus a, that's x, times b, that's 3, so we have 3x, plus b, 3 squared, it's 9, okay? Now, there are very seldom cases where this quadratic trinomial is going to factor. So ordinarily, when you get to this particular point, you're done factoring those. So that is the sum and difference of cubes, a very important pattern, and you do need to memorize those. There's no other way that you're going to be able to factor those things. All right, now, if special products don't give you the factors, then the next thing in the factor checklist, number 3, is the product of two binomials. Now, there's two there's two cases under product of two binomials. Let's just call them simple, and B, we'll call this one complex. Now, the way, or maybe not complex, we use complex for something else. Let's just say complicated. Now, something, a quadratic polynomial is simple if the coefficient of the squared term I need some room here. The coefficient of the squared term is 1. Let me see if I can give you an example or two of that. Say, for example, we have x squared minus 5x plus 6. Notice here we want to factor this. There aren't any common factors. It's not a special product. And so we ask ourselves, is it the product of two binomials? Well, if it is, it's simple because there's a 1 as the coefficient of the x squared. So the way you do this is you just put two sets of parentheses down and you unfoil it. See, the number that would go here and here, the numbers that would go there and there would multiply together to give you the x squared. In other words, they would give you the first. And that would be x and x. Now, the numbers that go here and here would multiply to give you this last number, and they would add to give you this middle number. So the question is, what two numbers multiply to give positive 6? You do have to pay attention to signs here. And add to give negative 5. Well, the answer is negative 2 and negative 3. And there it's factored. Let's try another one here. How about x squared minus 10x minus 24? Now, are there any common factors? No. Is it a special product? No. Could it be expressed as the product of two binomials? Well, let's try. Put down two sets of parentheses. We know x would go here and here if it works. And we're now looking for two numbers that multiply to give negative 24 and add to give negative 10. Now, I happen to know what it is. You probably know what it is too, but let me just illustrate this. One of the ways to figure that out, if you don't know what the two numbers are, or to look for them, is to list the factors, the factor pairs of this number. So we could say, well, how about negative 24 times 1, negative 12 times 2, and actually that's the pair right there. So we would say x minus 12 and x plus 2. Notice, minus 12 plus 2. Okay, so if you have a 1 as the coefficient of your x squared, then all that is required is to find the factor pair that multiply to give this last number and add to give this middle number, paying attention to the signs, of course. Okay, now, if the quadratic polynomial that you're trying to factor is complicated, and complicated basically means that the coefficient of the x squared is not 1 even after you've taken out common factors, then you're going to have to use a method that I refer to as the Dorset Method. Now, I believe that I showed you this earlier in the year, but let's just work on it one time again. Now, the Dorset Method works something like this. Let's imagine, for example, we have 6x squared. Let's give ourselves a 9x over here plus 9. And let's see if I can figure out a nice middle term here. 29x, let's use that. 6x squared plus 29x plus 9. First thing you ask, are there any common factors? And the answer is no. Second thing you would ask is it a special product? Well, 9 is a square, but 6x squared isn't, and you have 3 terms, so really you're going to have to go with no on that also. Can it be expressed as the product of two binomial factors? If it can, it's complicated because there is a 6 in front of the x squared. So we can't just say what two numbers multiply to give 9 and add to give 29. What we can do, however, though, is find what is called the master product. Now, the master product is the product of the leading coefficient and the constant term, including the signs, of course. So 6 times 9 is 54. Now, the question that you ask yourself now is what two factors of 54 add to give the middle coefficient, or in this case, 29? Well, once again, if you don't know, then just start listing them. 1 times 54. Now, 2, does 2 multiply by anything to give 54? Well, it does. 2 times 27. And if you look at it, 2 plus 27 will add to be 29. So we found the pair. We can stop here. Now, we do something a little different in this case, though, because of the complication of this. What we do is we split the middle term up into 2 terms using these two numbers. In other words, we're going to write 6x squared plus 2x plus 27x plus 9. Now, this is not factored, And it's still not going to be factored when we put the first set of parentheses in. But first of all, just let me mention that this sign here has to be a plus sign. If it isn't, make it plus a negative before you do go any farther. Now, at this particular point, put parentheses around the first two terms and the last two terms, leaving a plus sign in the middle. And then you factor each of those two binomials by common factors. The greatest common factor in the first binomial is 2x. You're left with 3x plus 1. Greatest common factor in the second binomial is 9. Take that out, you're left with 3x plus 1. Now, look here. 3x plus 1 is a factor of this term, and 3x plus 1 is a factor of this term, and we're adding them together. So the distributive property says you can take a common factor of 3x plus 1 out, and you're left with 2x plus 9. And it is now factored. Now, we can try one more of these. Let's do one that has a negative sign, negative signs involved too, so that we can kind of handle that. How about 5x squared plus, let's see, plus 18x minus 8. I think this will work. Let's hope so anyway. All right, now, first of all, common factors? No. Special product? No. Product of two binomials? Well, if so, it's complicated. So the master product is going to be 5 times negative 8, which is negative 40. Now, what two numbers multiply to give negative 40 and add to give 18? Well, negative 1 times 40, negative 2 times 20. We found it again awful quickly. So we're going to rewrite the middle term, 5x squared minus 2x plus 20x minus 8. Now, since we have a plus sign in the middle already, we're good. We can just put parentheses here and here. And now we ask, what factors can we get out of the first one? Well, the only thing we can get out of the first one is an x. We're left with 5x minus 2. And in the second one, we can get what? We can get a 4 out of there. And we're left with 5x minus 2. Notice this happens again. So we write this as 5x minus 2 times x plus 4. And we're done. Now, I'm sure some of you are saying, but Mr. McFarland, since it's negative 2 times 20, does it matter if you put the negative 2x first and the 20 second, or vice versa? Well, that's a very good question. I'm glad you asked that. Let's actually go down here with this, and let's do it again. And this time, we're going to put the 20x first and then the negative 2x. So we write 5x squared plus 20x minus 2x minus 8. Now, I've told you that this sign here has to be a plus sign, and it isn't at the moment. So you make it plus a negative, and then you can group the first two and the last two terms. And out of the first two terms, you can pull a 5x. You're left with x plus 4. And out of this second group here, you can pull a 2. But since there's a negative sign right inside the parentheses, that's your signal that you should pull out a negative common factor. So you take out a negative 2, and then you say to yourself, negative 2 times what gives me negative 2x? Well, x. And negative 2 times what gives me negative 8? Positive 4. And notice then x plus 4, x plus 4. So we can pull that one out. We have x plus 4 times 5x minus 2. And if you compare that with what we had already, you'll see that they're exactly the same. So it doesn't really matter which of the two factors you put first when you split the middle term. I would just say, as a general rule, if you have one positive and one negative, it makes sense to put the negative one first and the positive one second, but it'll work either way. All right, so now we have product of two binomial factors, either simple or complicated, and that takes care of that particular section of our factoring checklist. Now there is one more section to our factoring checklist. Let me kind of get that. And so the last bullet point or number in our factoring checklist is going to be grouping and or substitution. Now, you're going to see examples of grouping and substitution in the solution videos, and you've seen grouping already in the Dorset method some, but let me give you, say, one example. Okay, let's say, for example, you have AC plus BC plus AD plus BD, and the directions are factor this. Now, you take it through the checklist. Are there any common factors? No. Is it a special product? No. Can it be expressed as the product of two binomial factors? Well, the product of two binomial factors, the stuff that we did there was basically with quadratic trinomials, and we have 4 terms here, so probably not. The next question is, can it be factored if we group terms? And what we can do is we can try grouping, say, the first 3 versus 1, or the first 2 and the last 2. Let's try the first 2 and the last 2 this time. And whenever you group, you always want to see to it that if you have more than one term in the second group, that there's a plus sign outside. If there isn't, make it plus a negative before you do that. And then we're going to look at the first 2 terms and say, are there any common factors? I see a C in the first one. We have A plus B. And in the second one, are there any common factors? Well, I see a D, and if we take out D, we have A plus B. And lo and behold, look at this. We have A plus B as a common factor to both times C plus D. And it's factored by grouping. Now, substitution. Let's see if I can explain a little bit of substitution. One of the things that you're going to end up having to factor sometimes is things that are in what you would call quadratic form, okay? And so let me give you an example of something that's in quadratic form. If you have x to the 4th minus 5x squared plus 6, and you wanted to factor this, this is not a quadratic polynomial. This is a 4th degree polynomial. But if you'll notice, the exponents on the variable are in arithmetic progression. X to the 0, x to the 2, that's plus 2, and then x to the 4, that's plus another 2 for the exponent. So when you go from an exponent of 0 in the constant term to 2 to 4, that's quadratic form. Or you might have something like y to the 6th minus 3y cubed minus 4. Both of these are in what you would call quadratic form. They're not really quadratics, but they have that quadratic binomial feel, a trinomial feel to them. Let's actually take a look at this one just quickly. Now notice the middle term variable is x squared. What we do is we pick another variable, let's say m, and we let it be equal to that middle term. And then we say, what would we get if we squared x squared? That middle variable, x squared squared, actually is x to the 4th, and so that would be m squared. Now, if we substitute in for x squared and x to the 4th, we get m squared minus 5m plus 6. And this can be factored as a quadratic trinomial. We would have an m here and an m here, and then we would say what 2 numbers multiply to give 6 and add to give negative 5, and that would be negative 2 and negative 3. And so we'd have m minus 2 times m minus 3. Now, some care has to be taken here because nobody cares about m. That wasn't the job we were hired to do. We were hired to factor x to the 4th minus 5x squared plus 6, and we've just factored m squared minus 5n plus 6. But since m is x squared, we can substitute that back in to write it as x squared minus 2 times x squared minus 3. And so we look at those, neither of those factor any further, so we would be done with those. Now, you'll see a lot of examples in the solution videos on factoring, and I would just warn you about that and say, please, please, please pay attention to the solution videos, because this is very important and it does get complicated. One other thing, in your book on page 371, there is a block that says key concept. It talks about quadratic form. And the example they give in that key concept block is wrong. It is not quadratic form. Now the one above it in the paragraph is right, but that one is wrong. So ignore that one. Don't let that one confuse you. And that takes care of solving polynomial equations. Well, it doesn't really take care of solving polynomial equations. What it takes care of is factoring. But then what you do, if you're trying to solve a polynomial equation, you take your factor checklist and you set the quadratic polynomial equation equal to 0, you factor the polynomial, set each factor equal to 0, and solve those. And you'll see lots of examples of that too in the solution videos. So at this particular point, I'm going to sign off. We're done.